So remember, magnetic variation is an evidence of seafloor spreading, plate tectonics. Get a chance, copy this if you can from the PowerPoint, not type it in, and watch this video. It will really help to solidify what I was talking about. Now we are going to talk about plate boundaries, where the plates meet. This is called a convergent plate boundary. Convergent means to come together. So if you look over here, we have a top view, and it looks like two plates coming together. Now, the side view, or the cross section, is showing you that the oceanic plate is going underneath the continental plate. This is called a subduction zone. Now, what's happened? Still convergent, and subduction zone, same thing. What happens is, remember, the oceanic crust is more dense than the continental crust, so the plate will subside or go underneath the continental crust. Here is a picture of it, subduction zone, oceanic crust going underneath the continental crust to the point where it melts, and you're going to get volcanoes right here. I don't think this is going to work, but it's an animation showing you the same thing of a conduction zone. Second one is a divergent plate boundary. So what happens here is pretty much what we were talking about, the seafloor spreading. You have your convection cells, and the plates are moving away from each other, diverging. You should be remembering these terms, convergent and divergent, from when we did our wind patterns, right? High pressure, low pressure. Well, it's not pressure in this situation, but the plates are diverging here. And here is your top view, seeing the plates move apart. And again, not going to work. All right. Divergent, another diagram of it, mid-ocean ridge. That's the new magma coming up. And the last one we are going to talk about is a strike slip or a transform plate boundary. I like to explain this just looking at Peninsula Avenue. If you're looking at Peninsula, some cars going north, some cars going south, going past each other. That's what's happening here. All right. Going north, going south. This is a transform plate boundary. Transform plate boundary. Okay. Now, this is a diagram in the reference table, giving you a lot of information. So you can see these boundaries here. You can see the continents are the darker gray, but that's not the plate. The plate is the continental and oceanic. So the plate is the whole thing. If you're looking here, the North American plate, all of this is the North American plate, all the way around. Pacific plate, all of this, going all the way around. The Pacific plate, as you can see, is mostly ocean. Indian Australian plate, continent, oceanic. So the plates are much, much bigger than just the continents. Now, what they're showing you here also is the plate boundary. You will notice here, the two lines with the space is a divergent plate boundary. And it tells you divergent plate boundary broken up by transform faults, mid-ocean ridge. All right. Over here, subduction. Now notice, this side is the plate going underneath this side. So whatever side the little rectangles are on is the side that is the overriding, or the continental. And over here is the oceanic. The oceanic is going underneath the continental, right here. All right, so anyway you see that symbol, so look, oceanic going underneath. Transform plate boundary, my favorite one